All right, good afternoon, everyone. So hopefully you all had a chance to meet the TA on Monday. By the way, for those of you that may feel like you're having a difficult time with some of the concepts in here, the TA also leads the lab, right? So in the lab, they do exercises like what we've been doing in class. They'll have let's say quizzes that are almost Q&A sessions. Once you take the quiz, kind of go back and forth, and you get to talk about the different concepts that we've been covering during the week to try to get a better understanding of it. So just be aware that that is available to you, and it's immediately after this class. So we are going to finish talking about selection statements. Last week, we talked about if statements as one type of a selection statement. We mentioned that there were different, let's say, variations of how that could be written, right? Just a plain if statement. And with this example here, you have your Boolean condition and one or more instructions that are associated with that if statement, and they either get executed or they don't. So if that condition is true, we will execute this set of instructions. If it's not, we'll just ignore them. The second variation included a default section, right? A default clause. So I'll either do this set of instructions, or instead of just skipping and not doing anything at all, I'll just perform this default set of instructions. So if I don't do any of these, I'm always going to at least do something. And here's my default. And the important thing to note here is that anytime you have this default section, you never specify a condition. So this happens a lot. You never put a condition here for this default clause because there is no condition for this. The condition is nothing else was true. If nothing else was true, then I'm just going to do this, period. And the other variation where you can have one or more of these after your initial if statement. And these are just treated as sequences of if statements. They will be evaluated starting at the top. They'll be evaluated top down. And the first one that is true, the first one that evaluates to true, you will execute the instructions in that section and then exit the if statement, right? So this whole collection of statements here, all of these sections together are one if statement. Now we have multiple if statements within here, but each of these is a different section. So you can think about this as section 1, section 2, and section 3. And we'll just keep evaluating these conditions until we either find one that's true. So in this example, if this one is true, I'll execute this section and then leave. Or if nothing is true, we'll drop into this default clause here and we'll just execute this section. And this is optional. So the default clause is always optional. It's not mandatory. You may not have one. If you don't have one and every one of your if statements is false, you just won't do anything. You'll just skip every one of those sections. So the biggest difference here, again, is that we have the word else followed by another if statement. Else followed by another if statement. You can write one if statement after another, but that would not be considered one unit. That's considered two separate if statements. What do I mean by that? We'll just open one of these. You can do this if we'll just do something simple for now, right? So we'll compile this and run it. And if you look, at the code here, if we look at the diagram, right, the control sequence diagram, you can see that these are actually two separate if statements. This is not one big if statement with multiple sections. That's an individual if statement, and that's an individual if statement. But these two here, it's the same two statements, right? The only difference is I put the word else in front of this one. These two here, you can look at this and you can see these are actually one unit. So this is one big if statement that has multiple sections. Right? And the way this type of if statement works is that only one of these sections will ever be executed. We know that both of these are true, but we're not going to execute both of these. And if we run this, you can see that, right? These two statements are the result of these two print statements. So both of these if statements are true. Both of those sets of instructions were executed. But as soon as we got into this big one, this unit, you can see that we only executed the first statement because we treat both of these as one unit. And this was true. So as soon as we execute this, we just exit. Even though the next one is true, I don't even bother evaluating it. We just exit the block, if you would. Switch, here is where we were. We left off here. So this is the other type of selection statement that you can use, you can write in C. The switch statement is almost like this kind of if statement. It's not quite the same. There are differences, but it's almost like that. Some of the similarities you'll see are that it has multiple sections. So typically a switch statement has multiple sections. So if you look at this code here, this would be section 1. This is section 2, section 3, and then we have our default section. If we were writing this as this type of if statement, where you have multiple sections for one unit, then each of these cases is the equivalent to another else if block. So this would be the first if, and then else if, else if, else. So how does this work? Well, so the way switch statements work, you have your keyword here. So now we use the word switch instead of the word if. And then in the parentheses, some value. Typically, we're going to use a variable. The idea is that I don't know what that variable is. And I want to do something based on the value of that variable. I don't know what it is. It will have a value. And depending on what that value is, I'm going to make a decision. You can put just, but again, it doesn't have to be a variable. It can be the number 10 or the number 5, which would kind of be pointless because you know exactly what the value is. But switch followed by parentheses, followed by, and inside the parentheses, typically some variable. You have to have the brackets. And then you're going to define one or more cases. And this case, it's the word case followed by some value followed by a colon. And that value is what you think that's going to be. So for example, here, switch, and here's the variable I'm testing, and I'm going to define my first case. So case, and then 1. What I'm saying is, if the value of magic number is 1, here's what I'm going to do. If I were to write that as an if statement, I would say if magic number equal 1. That's the if statement that would correspond to that case statement. Then I would do this stuff here. Case 2, well, if it's not 1, kind of like the if else if this is not true, I'm going to look at the next case. Well, is magic number 2? Oh, it is? Okay, then I'll execute this. If it's not, we'll look at the next one, the next value, right? Is it number 3? And if it's none of those things, we have this default clause that always gets executed no matter what. It's just like the else statement in an if else statement. The other difference between this and the else if style of the if statement is that these are not exclusive. So with a switch statement, as soon as you encounter something that's true, let's say this were true, you start executing instructions and you don't stop. You execute every instruction below that until you're told to exit the block. So for switch statements, you have to manually exit that block. Right, so if we think about, let's take a look at this. I didn't have to tell C to exit this block. It knew what to do, right? As soon as this was true, I exited that block. But switch statements don't work that way. As soon as one of those sections is true, I just start executing every instruction below that one until you tell me to get out of the block. And how do you do that? Well, in C, you do that through the break command. The break command exits a block of code. So if we take a look at this code right here, magic number, scanf, you're going to type something into the keyboard. It's just going to have a value in it. If that value were 2, what would be printed on the screen? If you look at this code, based off what we just described about how switch statements work, what would be printed on the screen if magic number were 2, had a value of 2? I type a 2 into the keyboard. What's that? Okay, so it would print, you said this print statement here, and then that's it. So then it would print the next one, and then that would be it. And it also print the next one. Very good. Close, almost, but very good. It would execute every one of these instructions, and you said it exactly right, because you didn't put a break statement in here, or I didn't put a break statement in here. So it would execute this one. You didn't tell me to leave. Okay, I'm just going to start executing instructions until I see break or until I reach the bottom. Very good. This is just showing what that would look like if we wrote it as a bunch of if statements, right? If or else if statements. So if magic number equals 1, you know, that's the equivalent to case 1. That's really what we're saying here. Magic number, and then this right here is like this last part, the equal 1 part, right? Case 2, else if magic number equals 2, else 3, etc., and so on and so forth. So before we move on, do you all have any questions? Any questions about switch statements? All right, then let's do a quick exercise together in Canvas, and we'll do these in JGrass if you have, or you can do, if you have online, if you can't get JGrass to work, you know, you can go online, use an online compiler, that's fine too. In Canvas, you will see exercise selection. So if you click this, this is what I want us to do. I want you to display a list of options on the screen. Now, how would we do that? How would you display something on the screen for someone to read? In C, if we're writing a C program, what instruction would we use to display something on the screen for people to look at? Printf. So display this list of options. I want them to see this when they, first thing someone should see when they run your program: 1, add 2 numbers; 2, subtract; 3, multiply; 4, divide. So see those options. Then you should ask the user a question. Hey, choose one of these options, and use scanf to save their choice. Right, so they're going to type something in the keyboard, save what they choose, and depending on what they chose, just print out a message and tell them which option they selected. So for now, it's very simple, right? Display all these options, ask them to pick one, and when they pick one, tell them which one they picked. Now, I would like you to do that 2 ways. I would like you to do it with an if statement, with nothing but if statements, 1 or perhaps 1 or more if statements. And I would also like you to do exactly the same thing using a switch statement. So I would like you to use both of these approaches to try to do this. And oh, and finally here we have, I forgot to mention, if they choose an option that's not in the list, let them know. So if I choose 5, say, hey, sorry, not a valid option. You should have picked something else. So that's the exercise that we are doing for now. Simple exercise. Do it with an if statement, do it with a switch statement. I want to do this bigger. Oh, it does work. Why don't we do the first piece of this together? Let's go in here and see if we can do the first piece of this. Let's see, we know we're going to need to print things. So let's use our, let's import our input output library. We know we need a main function, right? We're not really writing any other functions for now. So we'll go ahead and create our shell for our main function. We know we need to somehow print this list. So there are a couple of options for formatting that. Let's say, why don't we save these into variables? So if we've been going through our Xi books, we should all be familiar with how to make string variables. So we can make at a very basic level, let's just say option 1 equals, and we'll just write down that sentence. What is it? Add 2 numbers. So 1, 2 numbers. Is that it? Add, to, subtract, multiply, divide. Add, subtract, multiply, divide. And we'll just do that a couple of times. Oops, we need our brackets, right? Because it's an array of characters. And we'll do that a couple of times. 2, 3, 4. So it's option 2, 3, 4. 2, 3, 4. Add, subtract, multiply, divide. And we know that the first thing we need to do is just display this list to whoever's using our program and ask them to choose one. So we'll just say that, hey, please choose one of the following options. And we'll put the actual options on the next line. We'll do a tab and a string. Tab and a string. Tab and a string. Actually, that's the wrong thing for tab. One, two, three, four. And what are the strings? Option 1, option 2, option 3, option 4. Let's just see if this displays the way we want it to. And there we go. So choose one of the following options. And we saved these as strings. And then here we just provided a bunch of format specifiers, right? So the \T that represents the tab character. So that's the equivalent to me typing tab in the keyboard. The \N, remember, that's like hitting return. So when you're using printf, you're literally telling the computer exactly which characters to push. Imagine you're telling the computer to press keys on your keyboard. This is what you're doing. You're telling it which keys to press. So I said, press tab, print this, press enter. Press tab, print this, press enter. Right, and remember these format specifiers, these are substitutions. So variable 1, 2, 3, and 4. You don't have to do it this way. You could just print it. You could have just written the entire message here. This is kind of nice later, right? Because later I want to be able to tell you which message you chose, which option you chose. And now I can reuse these variables if I want to. I don't have to retype that. I could just type option 1 or option 2 or whatever one it is. Why don't we do the first part of this? If I wanted to save your answer, how could we do that? So I've displayed something that you can see now. When you run it, you can read this message. Please choose one of the options. How do I capture that from the user? We could use scanf. So help me out, get me started. I just do scanf. And how does scanf work? Okay, so we have to make a variable first that we can use to store that value, right? So when you type something into the keyboard, scanf is going to capture that, and it has to put it somewhere. So before it can put it somewhere, we have to create that storage location. So we're going to make a variable, and then we're going to use it kind of like printf. I want you to scan a number, and I want you to put it right here. Remember, we have to use ampersand with scanf. The ampersand means go to that physical address and put it right here in this block in memory. And we can just, for now, print it and see what it was. Let's just see if number selected was, and we'll do the number. And we should, oh, come on. Select, we'll do 4. Number selected, very good. So this is not what I want us to do, okay? Now that we have this option, I want you to write an if statement or a switch statement that can utilize that variable. And what it should do is tell you which one of these options you chose. You chose option 1 or 2 or 3 or 4, but do it through an if statement and a switch statement. So do it with an if statement entirely and also with a switch statement entirely. All right, how many people went with if statements first? Anybody finished yet with that, at least? One person? Why don't we take a look at that one together? Let's try to think about the approach first. So what are we trying to do here? Based on this value, whatever that is, I'm going to do something. And pretty simple. If that's a 1 or a 2 or a 3 or a 4, I just want to tell you one of these things, right? Here's what you picked. Otherwise, I need to say, you have to pick a valid option. So what might that if statement look like? Let's start with the first one. How might I write an if statement for that first option there? If it's a 1. I know I need the word if, and I need some Boolean condition. What's my condition going to look like? What is the thing that I want to be true that would cause me to execute some instruction, right? So the instruction I would execute is you chose this option. What has to be true for me to say that? For me to want to say that, what needs to be true? What's that? It's really hard to hear you. Okay, how do you know that they chose 1? Look, if we look at the code here, there is a concrete way for you to know which option they chose. And that's what's going to go in this. We need that in here. So how do we know they chose option 1? That's correct. But how do we know that? Well, they're going to do that here. They're going to type it into the keyboard. I don't know what they're going to type into the keyboard, but they're going to type it in. They're going to type something into the keyboard, and we're going to save it somewhere. Conceptually, what I want to do is if they selected 1, if they typed a 1 into the keyboard, I want to display that message. You chose 1. How do I know that they typed on line 17? Remember, the code's getting executed from top to bottom. We're executing all these instructions. When I get to line 17, how do I know they typed a 1 into the keyboard? If option equals 1, because whatever they typed into the keyboard, regardless of the number, it's going to get saved into option. So if option equals 1, that means they typed a 1 into the keyboard. What do I want to do if they typed a 1 into the keyboard? There you go, print F, and we'll just say you chose, and we'll print the string here, and option 1. Very good. Well, let's do this on one line so we can save some space. Now, we could repeat that for the rest. Do we think that's a good approach? Is just to write 4 if statements, 1 for each of those options? That would work, right? Let's try that and see what happens. Let's do option 1, 2, 3, 4, and now we can just change this 1, 2, 4, and let's run it and see what happens. So we're going to compile it. No errors. That's good. Let's run it. Choose one of these. We'll choose option 2. You chose 2. Oh, that's great. Let's try it again. Choose 4. Okay, we can try all these options. Choose 1. Choose 2. So it looks like it's working. It seems to be working. There's one condition I haven't tested yet. Right? Which one am I missing? What do I do if they don't choose one of those options? Because I want to limit them. You have to choose 1 through 4. You can't choose anything else. So let's just see what happens if I do that. What if I type in a 10? I choose option 10. Oh, well, that's interesting. Nothing happens. So how do we fix that? An else statement. Okay, we could use an else statement. Where would I put it? Huh? Also, I would have to write an else statement after each of the if statements. Very good. So one else statement won't work, will it? So if we get to the end here, let's say we just tried to write it right after this one. When is the only time this default statement will get executed? Well, actually, we shouldn't say the only time. This, remember, these are 4 separate if statements, right? And every time I run my program, every single one of these if statements is going to be evaluated, and the instructions will potentially be executed. So here, when I get to option 4, if option is not 4, we're going to go into this else block and we're going to print you wrote the wrong option. That's okay if I write the number 10. But what happens if we choose number 1? Anyone? We could run it and see. Anyone want to guess what might happen if I choose a valid option? Well, let's see what happens if we choose an invalid option. So 10, great. So it looks like it works for invalid options. But what if I choose something like, let's say 3? Now, all of a sudden, I get both of these messages. I chose 3, and it's going to display my invalid selection message. Why did it do that? That is true, it is. But before it was working fine, right? As long as I was choosing incorrect options, it was only displaying that message and none of the other messages. But now I'm getting 2 messages. I really only want one, right? Either you chose the right option or you didn't. This goes back to why we need the type of if block that he suggested, your classmate suggested, but someone tell us why this is happening. That's correct. Very good. Every single one of these if statements is going to get evaluated, period. They're not exclusive. Every one of them is going to be evaluated. So when we evaluate this one, option is 3, and it just so happens 3 is none of the other choices. So this works. This style works if that's all we're trying to do. But as soon as we get here to option 4, well, 3 is not 4. So even though it was a valid choice, because these are not exclusive, I'm going to evaluate this if statement also. And this one's going to be false, and that's going to cause us to execute this else block here. So what we really want to do is limit our options so that only one of these things ever happen. I can never do more than one thing. I can only do one thing. And here, that's exactly what's going to happen. As soon as one of these things is true, I'm going to exit this block of code. Let's just compile it and we'll run it. And now it doesn't matter what we pick, right? If we pick an appropriate option, it's going to execute. This is going to be true. I'm going to execute the instructions associated with that option. And then we'll exit this block right here, this if block. Very good. All right, let's keep working. Try to finish the switch statement. Anybody finish the switch statement yet? Still working on it? Okay. I'll try to help get us started. We know we need the word switch. And I know we need our brackets. And in between these parentheses, I need some value. Typically, it's a variable. So what am I switching on? What is the value that I'm going to put between these parentheses? Option, that's right. This is what I'm going to be using to determine what action I'm going to take. Just like with the if statement, right? This is where we know what their selection was. It's stored inside this variable. So same thing for, depending on what this is, I'm going to do something. So let's do some of this together. With this style of if statement here, right? We divided each section by writing another if statement, right? So here we could look at this as like section 1, and then section 2 we have another if statement, else if, and finally we have this for our last section. What do we use to divide sections? To divide switch statements into sections? What word do we use? It's a specific word. Huh? Case, that's right. We use the word case. So we know this is how we divide switch statements into sections. And what should go after the word case? Okay, 1, but what is 1? What is the, we could start with 1, we could put something else there, but what is the meaning of that? Why is that what we put here with relation to the exercise that we're doing? That's right, 1 is the value that will determine whether or not we execute something. So in this case, if option is 1, right? If that variable has a value of 1, that means I want to do this instruction here. So that's the same thing. What does that mean? That means if option has a value of 1, we need the colon. What do I want to do? And then we can literally just copy and paste these instructions. We're going to do the same thing. So let's just paste that. And we would do the same thing for the other options, right? Just case 2, case 3, case 4, and then we would use default instead of if. And we'll just copy, we'll paste this a couple times. And we'll say 1, 2, 3, 4. So here's let's say this is a version 1 of our switch statement, right? So case 1, that means if option equals 1, execute this set of instruction. We just want to print what they selected. Or if option is 2 or 3 or 4, or if it's none of those, we'll do this. Let's compile it and run it and see what happens. So here, I'm gonna type in a 1. Oh, let's not do a 1 yet. Let's do a 6, something that we know is wrong. Oh, well, that's interesting. Why did it print that twice? Let's try it again. What if we do a 7? Oh, it's running this and the bottom one. Let's comment this out for now. We'll do a block comment so we don't have to look at this output and confuse ourselves. There we go. Now we'll type in a 9. And okay, that's good. Looks like it's working so far. And let's type in a 1. Whoa. What just happened here? Yeah, it printed all of my instructions. It ran all the print statements. Why did it do that? Because I didn't tell it to exit the switch statement, right? So this was true. That's great. I executed that instruction and I never used, what instruction do we use to exit a block of code? Break. That's right. So we didn't break out. So let's do break here. And now if we do the same thing, we type in a 1, it only executes that instruction and it exits the block. So is it enough? Is that good enough there? Are we finished? I need a break everywhere. That's right. Very good. So I actually need one after every single instruction. Now, why you might think this is weird behavior. Why not just make it inherent? Why not just make it the default behavior? Well, sometimes you actually don't want to do that. You can consider the use case where maybe you have a range of values, let's say 1 through 10. And if I choose any of those options, I want to do some set of instructions. Well, you could define case 1 through 10. Maybe you leave all of those blank, and then you just have all your instructions by 10. Now, it doesn't matter what that option is. If it's one of those values in that range, it's going to be true, and it'll just continue down until it executes that one set of instructions and then exit out. So sometimes you might actually want to execute sets of instructions that cross cases, and sometimes you don't. So with this approach, you have the flexibility of choosing for yourself which one you want it to be. With that, we are out of time. On Monday, we are going to do another exercise, but it's going to be for a grade. So Monday, we're going to do a graded exercise on Vocarium. I think it's going to be the first one we've done in here. It'll be just like this, though. You can work together. You can ask me questions. I would suggest you come to class. If you finish it before class is over, you'll get bonus points. Otherwise, you have until midnight to do it. So you don't have to finish it in class. You can finish it by midnight, and you'll still get credit for it. But you do have to complete it on Monday. If we don't have any questions, have a good weekend, everyone. I'll see you next week.